Hello, welcome back to the video series. We continue to review the Understanding Construction Drawings textbook. This video is about Unit 40, and that is HVAC and Plumbing Drawings. So we have two more units left, and that is Unit 40 and 41, which is Electrical Drawings. They are quite long, so please stay tuned. And after completing this unit, we will learn a few very important concepts. So we will identify the major pieces of HVAC equipment, and also will list the size of pipes and fittings shown on the mechanical drawings, and also explain the major functions of each. Also, we'll take a look at the air handling ducts and air handling units that are shown on the mechanical drawings. So we know that HVAC stands for heating, ventilating, and air conditioning. And plumbing is also referred to the mechanical systems. For residential construction, these systems are rarely covered in depth with drawings, and subcontractors who install the systems can do most of the work with the very minimal information shown on the floor plans. And that's, for the most part, just the architectural plans that they use. If additional drawings are necessary, those subcontractors will prepare their own, and usually that is enough to pull the permit from the authority having jurisdiction. But in commercial construction, the mechanical systems are more complex, and the drawings usually are included in the construction document set. So let's begin with the HVAC, or heating, ventilating, and air conditioning plans. So the HVAC system for a building larger than a single family home is designed by an engineer who specializes in this work, and mechanical engineer. And the drawings for this work are usually drawn on a basic outline of the floor plan for the building. So and then after that, the coordination is critical. So no pipes or ducts penetrate the structural elements. And the drawings allow the HVAC and plumbing equipment to be located properly in relations to rooms, walls, floors, and so on. Um, it is important to understand where and how pipes will pass between beams or through walls, and it's especially important when the ducts or pipes penetrate the firewalls. But we'll talk about that a little later. So most commercial buildings are heated by burning fuel up to this day, unfortunately, which is natural gas or fuel oil, and distributing the resulting heat in the form of warm air, hot water, or steam. Warm air heating systems require ducts throughout the building to carry the warm air to the occupied spaces and to return the cool air to the source. A warm air system has the advantage of allowing for inexpensive air conditioning. The same ducts can be used to distribute either warm air in the winter or cool air in summer. The ducts, however, require much more space in ceilings, plenum spaces, and walls, and are harder to route through and between structural elements than our pipes, for example. So when hot water or steam is used to transport the heat to the occupied space, two pipes are required. One is supply and one is return. So the basic type of system is readily apparent to the person who is looking at the HVAC plans. The plans for an air handling system include ductwork. And the plans for a hydronic system include more pipes and fittings. And that's the water system. Hydronic system is water system, and the other system is air system. And there are air and water systems as well. We'll talk about them in a little bit. So, as far as the unit ventilators, the heating plans might appear difficult, but we can go through them together. They are here in your textbook, so please refer back to the textbook. Videos are not enough to understand these concepts, and see how that is depicted, how that is graphically represented on the drawings. So you can see that each of the rooms um, have the uh, call outs there for UV1 and UV2, and those indicate that the building is heated by unit ventilators. That's what UV stands for. A unit ventilator is a unit that combines a means of mixing room air and outside air to ventilate the room while also warming it. And the warmth is provided by the hot water that is piped in from the boiler. So, there is an image here that explains the principles of a unit ventilator. The hidden controls include a function that controls the balance of recirculated inside air and fresh outside air. During the day, when the building is in use, the damper is open to allow more fresh air to be circulated through the room. And at night, the damper is closed, so less cool air enters the room, resulting in an energy savings. Also, the amount of air that is drawn in from the outside when the dampers are closed is as much as possible is indicated on the drawings, and also it is shown in on the schedule, and that is shown as CFM, or cubic feet per minute. Also, there is some other information that describes such things as the total amount of air that passes through the unit, the water temperature intended by the designer, and the speed of the fan, and some other information that is relevant. So again, please see the images here. In this particular case, in the package that is included with the textbook, the school does not include air conditioning. So, but in case if it did, the unit ventilators would be supplied with cold water when cooling is called for. So the same system of balancing inside and outside air would be used for energy conservation and fresh air. But instead of passing the air over heated pipes, it would be passed over cold pipes. And the schedule of unit ventilators would include information for AC as well. So the unit ventilators are only a few feet long, uh, yet the plans show a continuous string of equipment of some sort along the exterior walls of the classrooms. Although not labeled anywhere on the plans, the equipment is bookcases, and the construction notes refer to them. So the manufacturers of unit ventilators also manufacture bookcases and filler pieces that are designed to fit with the ventilators and fill the rest of the wall space. And these bookcases have a false back with space for pipes to and from the ventilators. So I just wanted to mention that, just because this practice is quite common. So in that case, you can mask the equipment and make it look less bulky in the room. In some spaces, such as stairways and storage closets, the heaters are not labeled as UV or unit ventilators, and these are cabinet unit heaters, or CUH, that mount on the surface of the wall and do not have ventilation capability, and fan coil units or FCU that are intended to provide more heat than ventilation. Again, so refer here to the schedules, and we are moving to the heating piping. So, what is important to understand here is that once the basic type of heating system has been determined, the next step is to understand the piping that carries water to and from the heating units. So, it's easy to spot the pipes on the heating plan, and a dashed line indicates return pipes, and a solid line indicates supply pipes. Pipe sizes are indicated by callouts throughout the plans, and fittings such as valves, elbows, and T's are represented by symbols. So there are standard piping symbols, but each drafter uses a few special representations of their own. So a symbol legend is often included with the drawings just because they may vary. Again, there are details, there are mechanical and plumbing systems. You need to be familiar with those. So pipes are easier than ducts to coordinate with structural elements because the direction of the pipe can be changed easily and frequently. And of course, they are smaller in size and or diameter. Pipes might run horizontally in the ceiling for some distance, then loop around a column and drop down to a unit ventilator. It is not practical to show the layout of all pipes with separate plan and riser views, and the common method for showing pipes where both horizontal and vertical layout is involved is to use isometric drawings. So plumbing isometrics is something that you also need to be familiar with and know how to draw that, know the angles, and know how to actually show the plumbing elements. So, where the pipes need to drop down from the ceiling to the level of the ventilators, they are shown, yes, they're usually shown in the isometric views. So, most of the symbols again are included in the symbol legend, and that helps to interpret the symbols as you trace the piping. And um, also, when you work with the drawings, if you have a book in front of you, it is recommended that you use a colored pencil to trace the piping because sometimes they get confusing, they intersect, and get a little messy, but it's easier to just track it with the color pencil. So also there is a valve, an elbow toward the top of the drawing, and then another elbow back to the right. And you can see that also the riser is not shown in the wall where it would actually be positioned, because doing so would bury the riser symbol in the wall with material symbols and other lines. So, and that's why the pipe going down is actually shown at an angle up and to the right. So this is the isometric position of the drawings, and at the level of the unit ventilators, the pipes are arranged in a special way to eliminate noises that might result from expansion and construction as the water temperature changes throughout the day. So, also, let's talk a little bit about air handling equipment. So the unit ventilators introduce fresh air into the school edition, and this is the case that we are reviewing here. And a separate ventilation system removes stale air from each room, and all the rooms except the smallest closets and the stairways are provided with a system of ducts and a fan to ensure air circulation. A louvered grill in the room receives the air and channels it into a duct that carries it to the roof, where a fan exhausts it to the outside. So also there are drawings um, explaining the designations for outlet and inlet grills. Please refer to that. The ducts that carry the air to the roof vent are shown by their outlines and do not indicate the sizes. And a square or rectangle with a diagonal line through indicates where the duct rises to the next floor or to the roof. Also, the number indicates which of the several exhaust fans on the roof the duct is connected to. So please pay attention to that. And also, you can trace the flow of air as it is exhausted from janitor's closet and then on the back to the first floor. Um, the damper or metal gate closes off the duct if it gets hot in a fire. We know that already, and if that penetrates the firewall, this is necessary because the building code requires fire-rated construction, and an open duct is a great place for fire to spread. The access floor at the floor the access door at the floor allows for maintenance and repairs to the damper. Um, Also, notes indicate the duct sizes, and above the second floor louver, the duct is, we can see that it's 8 by 8, and also it is offset an unspecified distance from the storage room. So please just pay attention to the numbers here. Let's talk a little bit about plumbing, and that is the final subsection here. So the plumbing consists of DWV or drainage, waste, and vent piping to remove effluent or wastewater, hot and cold water distribution, and fixtures. So DWV system is more complex for a building this size than for a house, for example, because a large flat roof collects quite a bit of water in a rainstorm. There must be a way to get rid of it. So the second floor plumbing plan shows roof drains. They're marked RD or roof drains, and storm drain piping indicated by a heavy line. Callouts along the storm drain indicate the size of the pipe and its slope, and give information about how the storm drain is to be coordinated with structural components of the building. So also on the first floor plumbing plan, we're still talking about the school addition. The storm drain is represented by a heavy dashed line indicating that that is below grade. So we do not see that. Storm drain and sanitary drain are separate systems. Please don't forget about that. The storm drain only needs to carry rainwater away from the building. The sanitary drain must connect to a sewer or septic system. Although the storm drain and the sanitary drain pipes cross near the janitor's closet, we can see it here on the first floor, they are not connected. So, and they never are. Um, Also, drainage pipes outside the building lines are installed by the site contractors, not the plumbing contractor. And therefore, the plumbing drawings only show the storm drain and sanitary drain to a point of 5 foot outside the building, and then the end. But it does not mean that there is nothing beyond them. That means that a different contractor is taking care of the rest at the site. And a note where each line passes through the building wall indicates the invert elevation or elevation of the bottom of the inside of the pipe. So The hot and cold water piping is similar to that found in homes, except that the hot water is a two-pipe system. A return hot water pipe allows the hot water to circulate continuously, ensuring that hot water is readily available at the point of use. The hot water supply and hot water return can be distinguished from each other by the number of short dashes in the symbol. And these are um, these are explained on the symbol legend. The hot water return, which is usually smaller than supply, maintains circulation to a point close to where most of the hot water will be used. And it's often not practical to continue a hot water return pipe to every fixture. Um, and also, you can see the riser diagram that shows the vertical arrangement of the piping, and you will see that there is no hot water return shown on these diagrams because the return is connected to the supply before the supply reaches the first fixtures. So please refer to all these drawings here. A plumbing riser diagram is only used to indicate design intent and does not indicate a piping route. The sizes indicated by the engineer are minimum sizes, and also the company preferences and local codes can dictate the largest sizes that will be used. The notes also on both risers are relevant for all the risers, and the vacuum breakers required are also required on other fixtures. So it is important for plumbers to know and comply with local codes. And for example, like here in riser 3, we see that the vent serving MB1 is offset 90 degrees below the fixture, and that is an illegal installation by most codes. And the plumber would install the vent pipe in accordance with local codes and not use the riser diagram as a guide for routing the pipe. Where the pipes seem to connect but are actually different piping systems, you can outline the pipe route with different color pencils to clarify the different piping systems. So I know that was a mouthful, but that is a very important chapter. And please refer to the drawings, please review them again, and that will help you understand. So that was it. Thank you so much for watching. I will see you in Unit 41.